Hello, everyone. Welcome to the episode number 9 of Convector Developer Office Hours. In this episode, I decided to base the show on some community questions that I've seen on the Slack going on. So there has been multiple members like asking like different questions on different topics, and I wanted to dedicate today's show to answer those questions for them. So if you are looking the show like in live and you have any questions, remember you can always go to the YouTube channel or to Discord and put your questions in there. Um, yeah, today I'll be covering most of the questions that have been found in the community. Also, one of the feedback that I got for the show was that 1 hour was being too much for the show. So for today's episode, I will be just doing 30 minutes of episode um, just to test it out if it's like a better length for the videos. And so if you have any comments about this, if you like it more or you like the 1 hour videos back, let me know in the comments or in the Discord chat. You know, so yeah, I think without more and more than we have limited time today, which is 30 minutes. I think I'll just start. Um, so I collected some of the questions on the community. Um, Most like some interesting questions that I found was, for example, I have this: how to integrate between two applications when deploying on the same hyperledger-fabric network. Uh, and well, it depends. Now, for these two hyperledger applications, two applications running on the same hyperledger-fabric network, that can mean having like two chain codes on the same channel. That can mean having two chain codes in different channels. That can mean like having two actually controllers or chain code based on control on convector in the same chain code. So the way that I will tell you that you can achieve that, if it's from an architectural perspective, convector exposes the controllers and the models, right? Uh, but you are not limited to use only these kind of structures. For example, if you have a common project that you are developing, like two applications, two convector applications projects on it, uh, you can create like a common library uh, using all the common functionality that you can have for your application, and having this as an external application in your external library besides the two chain codes that you have in your project, the two or more chain codes that you have in your project, and import it in each of the controllers and models and use the functions on it. So this way you can like reuse some of the functionality that is being used across all the two projects if they share any at all. The other part that you can use is the convector in-chain code adapter. I will share my screen just a little bit. Uh, so if you remember in the restructuring episode, convector developer office hours episode talking about that, we have this adapter fabric in Chaincode. And what it does is that it allows you to have multiple Chaincode projects. For example, in this one, I have the first CC, second CC, and third CC. You can treat each of those like a separate project, if you may, and how they interact with each other, since you cannot like invoke directly the controllers from one controller to another controller, is you initialize an adapter, which is going to be the in-chain code adapter. You create a client factory using the another controller that you want to invoke, and you pass this in-chain code adapter, right? This will return you the second controller instance. So this will be a convector controller client instance with the type of the second controller. You can see that is in the angle brackets in there. So whenever you want to invoke that another controller, you can just do second controller, pass some configuration, this configuration will be like you need to pass the current transactions going on. Since we are in a function in here, we get the this.dx. This.dx, remember, will be the current transaction going on in this contract right now. We have to pass it to this adapter. We also need to pass the channel where this other controller is instantiated. It can be the same channel or it can be a different channel. And we need to pass the chaincode name or on how this controller is being instantiated. With this configuration in mind, then you can just invoke whatever method that the second controller has. You can see here that the second controller has, I think it just has get and init. Let me just confirm that. Second controller has a function init and get. Yeah, so those are the only functions that we have in here. So we can invoke either of those functions back in here in the first controller. So this way you can have like multiple applications. And I honestly I recommend just having one chaincode when you create a convector project. Just create one chaincode. You can have multiple packages in a single chaincode. That is no matter for that. That is no problem. But when you install this, install it as a single chaincode. When I actually advise for you guys to have multiple chaincodes as for when you have completely different separate applications one from another. So for example, you can deploy in a network a participant registry chaincode, and this participant registry package will have all the necessary controllers and models to handle the participants, right? To like register participants, define administrators, and how these administrators are going to work, etc., etc. And then later in time, maybe you can develop an application like, I don't know, like a finance application, for example, and you create another chaincode for this finance application, and you deploy this chaincode separately from the participant chaincode, so you can handle both of them like separately, even though the financial chaincode depends on the participant chaincode. So in this example, you can see that those are two completely different couple applications. So for example, if you have like a financial application and then you are developing in another application an e-commerce platform, for example, start every single transactions in Fabric. So even though that the e-commerce application can use the financial application to like exchange tokens or things like that, those are two different pieces or components, and they can be developed individually or independently, if you may. So the way that you interact with those, if they are instantiated in like in another channel, or yeah, overall installed in a different chaincode, you can just use this in-chaincode adapter to make in-chaincode or inter-chaincode, inter-channel invocations between one controller to the other. And I will say this in conjunction with events is like the proper way on how you actually develop multiple applications for a single Fabric network and connect and integrate them with each other. I will actually advise you to, when you are creating a controller, a smart contract, actually a chaincode, to emit events, relevant events for the transactions that you are doing. It doesn't matter if no one is actually listening for those events right now, because it may in the future. So in the future, you may have or need to listen for certain events, uh, and you want like to know, like for example, when a balance account was updated, or when a new product was registered, or when a purchase was made, things like that. You can just emit events, whether you use it right now or not. You may in the future, and this will help you like don't having to create a new version of that chain code later in the future. just to add events and having all the members of the network to accept that. You can just, instead of that, just develop with thinking in events beforehand and then reacting to those events from your backend applications, uh, yeah, at your needs. So that was one of the questions that I had. Another question that I got was how to define your architecture. So actually, this is pretty subjective. Uh, I actually like to, well, I already give you a couple of examples and tips about how to architecture applications. In the term of the chain code, I prefer to do multiple packages that do like a small task. Like for example, if I am creating um, if I'm creating an e-commerce platform, for example, I'll create just a controller in model to handle the products. I'll create another controller model to handle the payments, another one for the users on this platform, um, another one to maintain uh, like cash flows or things like that, inventory, all this kind of stuff. You can just develop multiple independent packages. It doesn't matter. You will at the end will be in bundle up everything in a single chain code most probably. Uh, and yeah, there is this another tip like thinking in events beforehand. You can just start leaving like emitting events on the controllers to just be aware that you can hook them in the future from your backend application and do some actions with them. So this way you make sure you're not developing or you're not emitting events specifically thinking on one single application, one single backend application. You're developing your events just being generic on and emitting events on what is actually happening on the chain code or in the controllers. So this is a way. Uh, this is how I prefer I usually handle the architecture for the chain codes. In terms of the architecture for the whole application, I actually like to think, and I will just do a quick drawing here. Yeah, drive. Let's see. Let's create just a new empty PPT. So we can just throw some lines. In applications, you can think of on architecture like to being, sorry. So you can think of having the blockchain like a central piece that will be in here, right? And inside of it, you will have uh, multiple chain codes instantiated with channels on different companies being part of them. So you can have it like in here, and you can have it like in here. So this will be chain codes instantiated in a blockchain that they expose to the public certain functionality to the controllers, right? And then you have a couple of backend applications. You will develop one, but another consumer, another organization might develop their own application, right? And they will just start talking directly with the chain codes. So this chain code may just this backend application may just send a request to this chain code, but in the process that involves updating a record in this chain code, and maybe when this happens, this chain code emitted an event, and this event will be sent or broadcasted to this application too, right? So this may have been just sending an event, and when it sends an event, it will then just send a transaction to some other record in this chain code, and at the end, it will just make another chain code transaction to this another controller, the controller 2 or 3. This was 1, this is 2. And when it gets to controller 3, it emits an event and it notifies either this application 1 and it updates also application 2. So this kind of architecture is that the one that you need to think about on your own specific use case. It depends, like this all depends on what you're trying to develop. Sometimes you can just play with a single chain code if it's just a single application and multiple backends. For multiple backends, I actually recommend to use events a lot because that's a really easy way to integrate between two applications and keep everything up sync. Another architectural pattern comes actually before it gets to the blockchain. So this is actually another question I got in here is how to implement API security. So there has been some discussions in Discord about how you like protect your API or how to authenticate the users using the API and things like that. And there is a couple of patterns that you can have. You can have, for example, you know that you will be having like one certificate in the API, and that certificate is going to be talking with the peers, sending transactions with the peers. But it doesn't necessarily mean that you will only have one certificate. Like there are multiple patterns. You can have a database in here. See, I have a database in this application, and in this database, you record like a user password for each of your users and enroll with the certificate authority of the blockchain to generate a certificate for each of those. You will keep those certificates like in a private record in your application, most probably encrypted with using a derivative of the user's password to unlock that certificate and make sure that you cannot use it with their consent and things like that. And then all your users will send requests to your API. And after you pass some authentication mechanism in your backend, like if you are using JavaScript, you can use, for example, a library called Passport. I recommend it. It's really flexible and it has a lot of integrations with social profiles and things like that. And it does also support user and password authentication or authentication, so any kind of authentication. So after the user sends a request into your application and it confirms that it's you with your database, it will unlock your certificate and send the transactions to the blockchain using your certificate. So this way you can have multiple users. So in this scenario, the user sending the transaction to your API will be the same user sending the transaction to the blockchain. This doesn't is always the same process. So in this example, we have multiple users sending transactions to the API, right? And then we will have multiple users sending transactions to the ledger, right? This doesn't necessarily have to be this way. You can have another mechanism, like you will have only so multiple users sending transaction to your backend API, and your backend API will only have one certificate, and it will act on behalf of all the users sending the transaction. What you can do in here is including like a signature when you're sending the transaction from the user to the application, that they need to send a signature of a private key using a private key they have on their own ledger, on their own site, private key. So using the private key to send a message and the signed out message, and you previously registered that user with a certificate in the ledger. I will explain. I think this is some material for a blog post. I think because it's kind of complex. But just to give you an idea, you can register the certificate of this private key in the ledger and has have has the user to send a private the signature using the private key of the message they're sending to here. Uh, your backend application will send a transaction using the backend application certificate. There will be just one user on the certificate authority of the blockchain, which will be your application user. And then here in the chain code, you can use any library to verify that the signature that was sent on this original message and was transmitted to here actually corresponds to the certificate to this private key using the certificate previously registered on the ledger under your contract. So this is what I call a multi signature transaction, because it will have the signature of the actual transaction for Fabric, but inside the data that you're sending to your controllers, there will be another signature coming from the user, and you will be verifying that signature using the public key in your smart contract. So you will actually have to write the logic to do this. So as you may see, there are multiple patterns to handle all these user authentication problems in the ledger. Let's see, it's almost the 30 minutes. Let's see if I can answer another question. Chaincode events support multiple listeners. Of course they do. Let me check a repo I have in here. Or Cebu. I think it's in FabCar REST. Yeah, on this one. So on here, I have this server. Let me check. I think it was not in here. So I have the server. Oh, what was that? Let's take a look at the repo. So I have example of events in here. Yeah, convector example events. So actually, you can see is from the convector developer office hours number 5. So if you're seeing the video right now, you can just go and jump this episode at a time. And if we come to prescription, you will see a test file and you will see a listener. So for the events to work on Fabric, you will have to create a hub. And well, the way that you create a hub is using the adapter. So for example, in here, I have the financial adapter. You see the financial adapter is just a Fabric controller adapter, right? And I will best make you can just come here and copy this kind of logic, or you can do it just by yourself. You can just do financial adapter, channel, that new channel event hub. And you can pass in here all the peers or just one single peer of where you want to listen for the events. You usually just will be passing the peers that are your own, right? You won't be passing like any other peers on your logic. And also it has to do something with the network configuration. Let me take a look into the Fabric, yeah, network profiles, organization 1, yeah. So on your network profile, you will have this section channels describing each of the channels, where it describes the orderers for this channel, and it describes also the peers that will be using this channel. On this peer configuration, you will see this property, event source. So if event source is true for this peer, it means that this peer is allowable to use events or that you can broadcast or subscribe to events on this peer. Most of the cases you will only want to. This is a network profile from hurley, and it has both of them enabled. On a production environment, you will most want it to only have true for sorry, for the events of the peers that you actually own. So, well, you can pass the events in here, right? And then after you have a hub, you just call hub.connect true. This true is really important. If not, it will not return the data of the event. It will just return the name of the event. An event has been emitted on the chain code, but it won't send you like the actual data that you sent to the event. So this true is very important. And after you created a hub, you just register the Chaincode event. So in case that you want to have multiple events, which was the question that was asked in the community, you only like you can have just a single hub and register to multiple events, or you can also have multiple hubs if you want to handle them separately. Um, just be aware that mostly at the end of your application, you mostly want to disconnect from the event hub, because if not, it will be keep running forever. And in some cases, you want to subscribe to the event hub just for a single transaction. So if you disconnect, for example, in here, I call hub register chaincode event. I will be registering for the financial event. For in the financial chain code for the transaction success event, and I will be given this callback. And if I want this to be a single event, at the end of this function, I will call hub.unsubscribe, if I'm correct, if I remember correctly, the API. So you call hub.unsubscribe or hub.close, like that. And it will close all the connections for this hub. So in cases where you want to just do this, like connect on event by event basis, you will probably most want to create multiple hubs for each of the events that you register. Otherwise, you can just create one hub for the entire server and subscribe as many events as you want on this hub. So, I'm waiting 30. Let's see. Yeah, I think I'll leave this question and this another question. I don't know. Maybe this is fast. How can I make more peers with hurley? So if you go to the hurley repository, you will find that there is actually that's for users. So if you open this folder, code E, there is, if when you create a hurley network, there will be this folder created on your home directory, hyperledger-fabric network. I'll be open this in a new instance of VS Code, and you will see that I will have this Docker Compose in here, right? So in this Docker Compose, I have all the documents that get created with Docker, and we have an order in here, a CA in here, and I have a peer in here, coach V, blah, 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 all the other stuff there here. So if you want to create a new peer, you can just copy the data in here, duplicate it, like create a new instance, a new entry for this one, and you will have to update some parameters. For example, so it has to have its own certificate. So certificate and private, all the crypto material will have to be the same, new and dedicated for this new peer. So after you create or duplicate this section, you can come here, let's see, config tx, YAML, yeah. And you can, let me share what it is. CryptoConf is actually, sorry. So you come here and, yeah, this one, and template account one. Yeah, so in here, you can just, you see that it starts just that count as one. It will generate just a single crypto material for a single peer. If you change these to a 2, 3, 4, 5, whatever, and then generate the crypto material again, if you just run restart, it will run everything again. It will have generated a new crypto material, and then you can come to the Docker Compose and uh, update the parameters that you pass to the new peer configuration in here. To point to the right folder, it will be most probably be called peer one or peer two or peer whatever. Although since hurley is meant for local development only, it will make much more sense to have multiple peers, because having multiple peers means, well, more RAM, more memory RAM that will be consumed from your local machine, and the transactions will have to take longer because they will have to be processed on each of the peers. And when you install Chaincode, it will take more time because you have to run npm install for each of the peers when it gets installed and things like that. But if you guys ever need to simulate how is to handle multiple peers, you now know how to do so by changing the configurations in this folder and running restart to generate everything again. So just you just make the changes, and then you can just call bash start, and that's it. That will generate the network again. That it will tear down the current network, and it will generate the network again. So there you go. So thank you very much for joining today's video. Um, Remember to subscribe to the videos if you like them. Leave a comment if you have any questions about Convector or how to do things and things like that. Or you can also go to our Discord group, and we have a pretty active community in there. Almost all days we have some questions. I see on Walter answering questions almost all day. Um, so yeah, please come by, pass by, and say hello, or if you have any questions, just leave it in there. Also, I wanted to remember. Oh, one important thing before I leave. Uh, so I just released before starting the video a patch version of Convector, like 1 hour ago, version 1.3.5. What changed only was not too much. It was just a couple of bug fixes. It was in there pending to be released. Um, uh, a bug fix actually for using Convector with Angular or any other browser libraries uh, that I talked on last episode. So yeah, just if you want to be on the latest version of Convector, be sure to update to 1.3.5. And yeah, and another thing before that is, so we have a couple of issues in here. I was just taking a look. I was probably going to take some time this week to do a couple of them. Some of them are improvements and adding new things to Convector. You can pass by and take a look. And there are some where I flag them as help wanted. So you will see this and you will see his help wanted. Those are we're open for community contribution. Well, we're open for all of them, but those are good to get started contributed to Convector. So if you find Convector valuable, please pass by and take a look if you can just have a little bit of your time and contributing back to Convector. We'll appreciate that a lot. So yeah, without more, thank you very much for joining this week, and we'll see you in 2 weeks. See you then.